Welcome to the presentation. Register games extend two-player games to infinite alphabets. And we consider alphabets with order, for example, natural numbers or rational numbers. There are two kinds of states. Adam states are boxes and if states are circles. In these games, there are two registers. There is register R1 and register R. On the edges, we have tests which test input data with respect to register values. And there are assignments which tells how to update the registers. And the same for if. There is a test and there is empty assignment. So how the play proceeds? The play starts in the initial configuration Q0 and all registers are 0. Then Adam picks a data. He can pick any data he wants. For example, he picks data 5. Then we look into the edges from the Adam state and find one edge where the test is satisfied. For example, here, 5 is greater than 0, the value of register R1. So we pick this edge. We go into the next state, next configuration, and we update the register. We save into register. We save 5 into register R. So the configuration is Q1, 0, and register R becomes 5. Now the same thing happens for if. If can pick any data. For example, let's say she picks 3. Then we look into the tests of edges, and here we see that data 3 is greater than 0 and less than 5. So if can pick this edge, and the assignment is empty, so we don't update the registers, and we get the configuration Q205, and so on. So the play is an infinite sequence of configurations. And the acceptance is defined with respect to the vertices. What are the strategies? The strategies have to generate data, but they don't actually see the data of their opponent, so they depend on test only. Such games are very expressive and they can simulate to counter machines. For example, in the example that I showed you above, this is actually simulates the increment of the counter. Adam tries to provide data, next value of the counter here, and then if checks whether the counter is correctly incremented or not. So we consider one-sided games. In one-sided register games, only Adam provides the data, while if generates a label from the finite alphabet. The strategies become Adam still has to generate the data, but if becomes a standard Boolean strategy. We show the following results. First, these games are decidable for natural numbers in exponential time in the number of registers. Second, finite memories strategies are sufficient for if to win this game. And finally, determinacy. If loses this game, then Adam has data strategy which beats any if. And how do we do this? The proof techniques is we reduce to finite arena omega regular games. In order to do this, we abstract away from the data and we keep track of order between the registers. This is a folklore idea and it's sufficient to solve the case of rational numbers. For natural numbers, it's much harder. And it's we devote the whole section on study of satisfiability of constraint sequences. This is also somewhat known result, but there is much more to this. We also need to really rely on game semantics, on finite memories and determinacy of omega regular games in order to get these results.